In this video, we are going to focus on solving polynomial equations, but specifically by the method of factoring, okay? So a few things. Start up here on the top left, we say just as we solve many quadratic second-degree equations by factoring, we're going to be doing polynomial equations in general by factoring as well. So what we're really doing is we're going to set it equal to 0 and then utilize what we refer to as the zero product property, which basically states, look, if you're multiplying a bunch of things together, and you get an answer of 0, then really one of these things had to itself be 0. So when we factor polynomials down into their bits or their parts, we say maybe I factored a polynomial and I came out and got these factors right here, x minus 3, and it all equals 0. The beneficial thing about this is we can actually solve this. We could set each of these factors equal to 0 and solve them. So we say like x plus 3 equals 0, or x plus 2 must have been 0, or x minus 3 must have been 0. If I multiplied all those blue things up there together and I got 0. And solving each of these leads us to essentially an easy to find solution, but we'd say x plus 3 equals 0, well then x must be negative 3, or x plus 2 is 0, so x must be negative 2, or x minus 3 is 0, so x must be 3, and we can find the answers quite easily. So this is why we want to be proficient with factoring, okay? So setting things equal to 0, factor it out, and then once you get everything factored, we'll set each of the individual factors themselves equal to 0. So that's our ambition. So let's go ahead and start. We say solve the following polynomial equation by factoring if possible. And then I mentioned here, if we had a graphing utility, we could go look at the graph and put a crude sketch of it, but really what we're finding are x-intercepts. So that's what the graph is good for. Letter A here, we have 2x to the fifth. Let me rewrite this here. We say 2x to the fifth plus 24x equals 14x's cubed. So the really important thing right off the bat is this. If it's not set equal to 0, let's go ahead and do this. We're going to subtract 14x cubed from both sides. And so we end up with this. We say 2x to the fifth. And I'm going to write this in standard form. So minus 14x cubes plus our 24x. This all equals 0. So now, somebody asks you to go solve this. It's kind of hard to get x by itself when you have like x to the fifth, x to the third, x to the first. So what we're going to do is we're going to factor it, starting with a greatest common factor. This is the first thing you should always check for. And in this instance, I noticed that, say, 2, 14, and 24 all have things in common. We could factor 2 out of each of those. And everybody also, x to the fifth, x cubed, x to the first, we could give an x out of everybody here. So we say factor a 2x out front, and let's write what's left. So we'd have x to the fourth after taking out that first 2x. Let's see, negative 14 divided by 2 is negative 7. And then it's be x squared since we took 1 out. And then 24 divided by the 2 out front, we say is plus 12. We have no x's left there. Okay. The nice thing about this is we can say, well, let's try to factor this. And it looks to me to be in like quadratic form. It looks like a quadratic thing. So we're going to factor this because it is in quadratic form. It may not be factorable, we have to give it a shot though. So I have something in quadratic form with an a value of 1, which is nice because that means I can just put an x squared and an x squared here. If this is going to work, then we need two numbers that multiply out to be a positive 12 that add up to be a negative 7. So thinking about this, I'm thinking, let's see, they multiplied out to be a positive, they added up to be a negative, so they must both be negative. And two numbers that I could add that are both negative that multiply out to be a 12 and add up to be a 4, or a 7, excuse me, would be 4 and 3. So I'd love to tell us that we're done here, but I do recognize that this thing right here is actually a difference of two squares, a DOTS, difference of two squares. And so difference of two squares, that's going to factor even further. So we get 2x, we're just going to carry that down. We say this factors into conjugate pairs, and then this one here we get x squared minus 3, we'll just carry it down here. So this one, being a difference of two squares and factors out into conjugate pairs, we say, well, what could you square to get x squared? X. What could you square to get 4? 2. So now that this is completely factored, what we're going to do is we're going to take every single factor and set them each equal to 0. This means we have to set 2x equal to 0. We have to set x plus 2 equal to 0. We have to set x minus 2 equal to 0. And we have to set x squared minus 3 equal to 0 and go solve each of these. So in this first instance, solving this, we'll just divide both sides by 2. And so we get, well, one of our solutions then is 0. Furthermore, if I were to solve each of these two equations, x plus 2, x minus 2, here I'm going to get x equals negative 2 after subtracting 2 from both sides, and here I'm going to get x equals positive 2 after adding 2 to both sides. This one here, we're going to solve by using square roots. So we're going to add our 3 to both sides. So we say plus 3, plus 3. 3's cancel, so you get x squared equals 3, and to undo our squared, we'll do a square root. So we actually get two answers here, and they happen to be plus or minus radical 3. Okay, so we got 5 total answers. And you know, one thing I guess to mention before moving on is this, hey, it was a 5th degree thing. We got 5 answers. Maybe there's a connection there. So moving right along, let's go ahead and say I want to solve for letter B. The nice thing about letter B here is this, that says 2y to the 5th minus 18y is equal to 0. It's already set equal to 0. So again, we're doing this by factoring with polynomials. And so I recognize here that these both have a 2 and a y in common. So we'll take the 2y out front. And we say, well, then left here I'd have y to the 4th minus 9. Okay. So I suppose we have this times this equals 0. We could set each one individually equal to 0, but I'll tell you what, this right here is also in quadratic form, or at least it is a difference of 2 squares, okay? So if you're thinking, okay, well, x to the 4th, or sorry, y to the 4th, that's not a square. Technically, y to the 4th is y squared squared. So if that's the case, then we could rewrite this as conjugate pairs. That's what differences of squares factor into, so plus minus. You know, we can start with a 9. What could you square to get 9? We get 3 and 3. But what could you square to get y to the 4th? Well, we said we could square y squared. So y squared, y squared. So we're going to solve all of these now. So we say, well, if this times this equals 0, well, then either 2y equals 0, or y squared plus 3 equals 0, or y squared minus 3 equals 0. So we'll start with the easy ones first. Like this guy right here. We say, okay, well, I would add 3 to both sides. Say y squared equals 3. So we take the square root of both of these now, and we say y equals plus or minus radical 3. So there are 2 of our answers. This one over here on the left is actually easy to solve as well. If we divide both sides by 2, we get y equals 0 divided by 2 is 0. And then last but not least, this one here is interesting. I don't know if anybody already recognizes, but when we subtract this 3 from both sides, we take the square root of this 3. It's actually taking the square root of a negative. And so what this presents us with is 2 imaginary solutions, or 2 imaginary solutions. So to make this positive on the inside again, we'll put a plus or minus I out front and call this radical 3. So there are 5 solutions there. 0, plus or minus radical 3, and plus or minus I radical 3. So 2 more to go really quickly. Letter C, we need to start by setting this equal to 0. And that's just a typo on my document, but we say, okay, so x cubed minus 27 equals 0. In order to solve this, what we're going to do is factor it, of course. I notice that these don't have any common factors, but I do recognize that it is a difference of 2 cubes. So as far as how differences of cubes factor, we get first of all a binomial times a trinomial, okay? Second of all, we say, well, what goes in the binomial is what I would cube to get x cubed and what I would cube to get 27, and this right here says we're going to maintain a negative. And then the signs over here when you factor a difference of 2 cubes or a sum of 2 cubes, the last term is always positive, and then this term here, this first term in the trinomial is always the opposite of what you started with over here. So to get these terms in my trinomial over here, we say, well, you take x times x is x squared. And then you take x times 3 is 3x. And then you take 3 times 3 is 9. Nice thing about this is, and I'll make you a promise here, this is not factorable. Not factorable. If you factored a difference or a sum of 2 cubes, this trinomial is not factorable. So what we're going to do is we're going to set each one of these factors equal to 0 now. If this times this equals 0, well, then either x minus 3 equals 0, which gives us a solution of 3, or x squared plus 3x plus 9 equals 0. So in this instance, to solve it, if it's not factorable, what we're going to have to do is use the quadratic formula. So since it's quadratic and we've got it equal to 0, we say a is 1, b is 3, c is 9. Then we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and we say b, well, we have a b value of 3 and 3, an a value of 1 and 1, and a c value of 9. So what we end up with is this, x equals negative 3 plus or minus, this is all over 2 times 1, but we get 9. Now a negative 4 times a positive 1, positive 9 gives us a negative, and then 4 times 9 is 36. So you could see here that we're actually going to sketch out some negative numbers in here. So we get negative, I believe 9 minus 36 is negative 27. So it's all over 2. And then furthermore, we'd have to simplify this because we have a negative in that radical. We'll have to put an I out front. So this is positive 27. It's all over 2. Even better, we say negative 3 plus or minus I. I know that 27 is 9 times 3, and I know the square root of 9 is 3, so we'll put a 3 out front. So we get this, negative 3 plus or minus 3i times the radical with that 3 left inside all over 2. So those are our solutions there. And then last but not least, Letter D. Letter D we're going to do because we have to actually set it equal to 0, bring this constant back over. So we get this. 3x cubed plus 7x squared minus 12x minus 28 equals 0. And because this has 4 terms, we're going to try this by grouping. So I have to tell you this here. This negative on the 12 has to stay with your 12. So we're going to put parentheses around the first 2 and second 2 terms respectively, but we'll squeeze a positive in between these. So we say, well, what do the first 2 things have in common? Well, they have x squared in common, x squared. So I get this. 3x plus 7 is left on the inside. Plus now, this is that plus that I squeezed in from up there. A negative 12 and a negative 28. It looks like 4 goes into both of them. So we're going to factor out actually a negative 4 from both of these, negative 4, to get these to be positive again. And negative 4 from the negative 12 there leaves behind a 3x. And then negative 28 divided by negative 4 is a positive 7. This is good. It equals 0 because these now both have a 3x plus 7 in common. So we're going to take the 3x plus 7 out front, and we get this 3x plus 7 times x squared minus 4, and this all equals 0. So now it is completely factored, well, not completely factored, but it is factored, and we could set each individual factor equal to 0, but this right here recognizes a difference of 2 squares. So we say now 3x plus 7 times x plus 2x minus 2 equals 0. And then we could set each of these equal to 0 and solve. If you do this, if you set 3x plus 7 equal to 0, you're going to get x equals negative 7/3 when you solve it. And if you set x plus 2x minus 2 equal to 0, you get positive and negative 2 for answers. So those are our solutions. Cheers.